Okay, what I want to do is just work some of the homework problems in section 2.1 and highlight a few things. Some things I even probably did not mention in class, so I may cover a few points I missed. Let's start with, I'm trying to do one homework problem out of each section, just to give you an idea, an example of the homework. Let's start with problem 6. Once again, this is section 2.1. We're learning about taking derivatives and what they also call differentiation. Let me read the instructions, and then after I read it, I can interpret sort of what the instructions actually mean. It says, compute the derivative of the given function and find the slope of the line that is tangent to its graph for the specified value of the independent variable. That is really nice math language. I will try and restate that once I write the problem. So here's a function. If we were to graph this, this would be, looks like a parabola. So it'd definitely be a curve. So they're saying, first of all, determine the derivative of this function. Let's talk about that for a minute. I think in class I actually forgot to mention the way they like to denote derivative of a function is you put a little tick mark here. Now here's the formula that we use to take the derivative. F of x plus h minus f of x all over h. And the limit of this calculation as h approaches 0. So let's go ahead and do this. F of x plus h means you take your function, your f function, and every place I have an x, I'm going to replace it with x plus h. So if my function is x squared minus 1, it sort of makes sense. Instead of x, I'm going to have x plus h squared minus 1. So this right here is my f of x plus h. Now it says to subtract f of x, and just to be very careful, I always put brackets here to make sure I subtract everything inside, all of f of x. Well, here's f of x, x squared minus 1. So right there is f of x. And this whole thing goes over h. And then sometimes I put big brackets around the whole thing just to sort of say the limit of this whole thing as h approaches 0. Now I need to go in here and do some simplifying. I'm going to multiply out these parentheses, get rid of these brackets, and see what happens. Now when you do this, if you do things properly, some things always cancel out. X plus h squared means x plus h times x plus h. Hopefully your algebra skills, if you FOIL this, you end up with this right here. So I have x squared plus 2xh plus h squared minus x squared, then minus a negative 1, which is plus 1, all over h. And now if I go to this numerator and I try and simplify, I notice I have x squared minus x squared. Those just cancel out. Oh, I forgot this minus 1 up here. here was my foiling, and then minus 1, I forgot, then minus this, because this minus 1 and this 1 cancels out. So when I'm all done, I have 2xh plus h squared over h. Now when you're doing these derivatives this long, tedious way, you should have things canceling out at this step. If things don't cancel out, then you need to check your work because you probably made some sign errors or something. So now I look at this. I've got an h in the denominator. I've got two terms in the top, but I've got an h here and an h squared here. So I can cancel an h out of all three of these. If that's not clear to you, think about factoring the numerator. If I were to factor an h, so then h's cancel out. I'm left with 2x plus h. Now I'm going to take the limit as h approaches 0. When you take a limit, first attempt is you just stick in the number into the variable. And if nothing goofy or strange happens, then you've got the limit. If I stick in 0 for h, this whole thing equals 2x. That seems perfectly fine. So now the derivative of x squared minus 1 is 2x. Now, one meaning of the derivative is the slope of the tangent line. Let's try and explain again what this means so you understand it. Because what happens is, I think I can graph this just to make it very clear. Probably looks something like this. So this right here is the function. What this is saying, if I choose any point on this curve and I draw the tangent line, so if I go to, say, at 2, and I try and draw the tangent line, I can find the slope of this tangent line because the derivative is the slope of the tangent line. And since I'm at x equals 2, I just plug in 2. The slope of this tangent line that touches the curve when x is 2 is 4. What about if I were to look and find the slope of the tangent line when x is 0? I think, according to my graph, so there's the tangent line when x is 0. And I plug in 0 for that. I can write it like this. The derivative when x is 0 is just 0, and that looks correct, because this looks like it has a 0 slope. So I show you this to point out what have we done. When we find the derivative of a function, this gives us the ability, once we choose a point, any point on this graph, any x we choose, at that point, if we look at the tangent line, this equation gives us the slope of the tangent line. So obviously, when you look at this curve here, the tangent lines continually change. It's according to what your value of x is, which makes sense because here it says this is the equation for the tangent line. It's changing all the time, and it depends on what x you choose. So for this problem, they said, hey, go find the slope of the tangent line when x is -1. So basically, we take equation for our derivative, and we plug in x is -1, which is maybe, I don't know, I guess it's right here. That sort of makes sense. This right here is a negative slope. It's -2. All right, so that's the first problem. All they want you to do is first find the derivative. And then once you have the derivative, then to say, okay, so since you know that the derivative is really the slope of the tangent line, here's a point, x equals -1, and go actually calculate the slope of that tangent line. All right, next group of problems. How about number 18? This one says, compute the derivative of the given function and find the equation of the line that is tangent to its graph for the specified value x equals c. So now they're giving us another function. And here they do this thing where they say c equals 1. All right, first thing they say is to calculate the derivative of the function. All right. Once again, just to make it very clear, we have a formula or an equation to find the derivative of a function. And it's the limit as h approaches 0 of f of x plus h minus f of x over h. So once again, based upon this function, let's fill in all this stuff. F of x plus h, 2 minus 3, it's x squared, so it's going to be x plus h squared, minus f of x, so minus the function, all that over h. There we go. Now we need to go in here and simplify. When I FOR this out, I get x squared plus 2xh plus h squared. If I get rid of these brackets, it's going to be minus 2, then minus a negative 3x squared, all over h. Now let's get rid of these parentheses. So 2 minus 3x squared minus 6xh minus 3h squared minus 2 plus 3x squared. So you can see this is just a lot of busy work. Now let's combine like terms in the numerator. 2 and minus 2 cancel. Negative 3x squared and 3x squared cancel. It looks like I'm left with negative 6xh minus 3h squared over h. So once again, at this step, you should have things canceling out. If you don't, then you might have a problem. And normally at this step, a lot of times this h will cancel out. So I got an h here, h squared here, and h here. This reduces down to minus 6x minus 3h. Now when I take the limit, if I set h equal to 0, so the derivative of this function is negative 6x. Now in that first problem, what they did was they gave me a value for x, and they had me calculate the slope of the tangent line. Because once again, the derivative is an equation for the slope of all the tangent lines for that function, for that curve, for that graph. So the first problem, I just plugged in a value of x and got the slope and we were done. This problem, they don't want just the slope of this tangent line. They want the equation of the whole tangent line. So in other words, if I had a graph like this, the derivative can tell me the slope of my tangent line, but they want the whole equation. Typically, the equation of a line is y equals mx plus b. They want the equation of the line. The slope is right here. The slope is the m, but they don't just want the slope. They want the equation of that line. Now, for us, this c equals 1, this is a way of saying, really, x equals 1. So we want to go for x equals 1 and look at the tangent line and find the equation of the tangent line at x equals 1. I can put it here. We want to find equation of tangent line Here's what we're going to use. There's an equation you learned way back in algebra called the point slope, which means if you have one point and you know the slope, then you can get the equation of the line. So for our line, first let's get the slope. We can get the slope of our line through our derivative. We'll call the slope m. So we want the slope when x equals 1, right? Because this is the equation. So it's negative 6 times 1. So the slope of our line is now minus 6. Now if I can find a point on my line, then I can use this point slope equation and I'm pretty much done. A point on the line. Well, I know they've already given me, they've told me x is 1. So I need to figure out what y is, or what you can think of y as f of x. It's very simple. If I know x is 1, what would y be, or f of x? You go back to your original equation. You can think of this equation as y equals 2 minus 3x squared. If I give this equation, I said, let's go find some points. How about let's find the point when x is 1? What would you do? You plug in x equals 1, and you get 2 minus 3, and you say, okay, when x is 1, y is negative 1. What is that? That's a point on your line. So when x is 1, the actual point on the line is 1 minus 1. So now we've got the slope of our line, we've got a point on our line, and the equation for point slope where m is the slope and x1, y1 is your point. So I'll put y minus y of my point, which is 1. Y minus a negative 1 ends up actually being y plus 1. The slope is negative 6. X minus the x of my point. And now let's go ahead and multiply out the parenthesis. Let's subtract 1 from both sides. So the two parts of this problem were find the derivative of the function, and then when x equals 1, find the equation of the tangent line. All right, not too bad. Okay, let's do a few more problems. Here is number 30. Instructions for 30 are find the rate of change dy dx where x equals x0. All right, let me explain this now. Here's the problem, y equals x squared minus 2x. This is called x naught. All right, so now we talk about some notation. I think the first two problems I've done, when they've given me the problem, they have written it in function notation. F of x equals 2 minus 3x squared. The first problem was f of x equals x squared minus 1. Well, hopefully you remember from way back in math is that y and f of x are interchangeable. Probably in algebra, you first learn to work with these equations, y equals this, and then at some point they begin to introduce function notation, so you begin to use f of x. These are interchangeable. So now they decided to give me a problem. Instead of writing it like a function, they just wrote it like an xy equation. Now normally when you have a function and you want to get the derivative, they just write it like this. But when they give you a function written with a y and they want to find the derivative, here's the notation they use. And you pronounce this dy dx, just like the letters. Dy dx. So these are both the same thing. These are both derivatives. They're just written differently. So they're saying for this problem, find the derivative, but they want you to write it dy dx. So the actual formula is the same. Now here, even though it's not a function, I'm going to pretend it is because that's just how we learned to write this definition. Of course, we know that function f of x and y are the same. So now if I want to find the derivative, I'm going to go to my equation. Every place I have an x, replace it with x plus h. So x squared becomes x plus h squared. Oh, let's not forget x plus h squared minus 2. So this whole thing is my f of x plus h. Now I have to subtract f of x and all that over h. Sounds like we've got a noisy fan in here. Now, got to multiply out all these parentheses. see what happens. I got to FOIL this. X squared plus 2xh plus h squared. Be careful here, minus 2x minus 2h. Here, minus x squared minus a negative 2x. All over h. Now I'd like to combine, simplify. Those two cancel. Negative 2x and 2x cancel. I think that's about it. So I have 2xh plus h squared minus 2h all over h. And hopefully you see I can cancel a h out of all these terms. So I have 2x plus h minus 2. Now if I take the limit as h approaches 0, I go and plug in 0 for h. Nothing unusual happens. So I say the derivative of this original equation, let me write it down here. Now it's funny how, let me just show you, dy dx, this is a derivative, but they also give it a different name. Just so you know, in their problem, they said find the rate of change dy dx. Sometimes they call this a rate of change. Now they say, do it, find the rate of change when x naught equals 1. Basically, sometimes I write it like this. Here's your derivative. And they say, we're going to go figure out this derivative when x is 1. So you plug 1 in for x. Turns out the derivative is 0. Which is interesting, but sometimes that happens. Okay, so that's problem number 30. Now let's go to 34. 34 is, hopefully notice so far these problems have been pretty much the same, just finding the derivative. 34 has got a little bit of a twist to it. 34 says so they start out by giving us a function. Now we're back to function notation. And there's a part A. Part A says, compute the slope of the secant line joining the points where x equals 0 and x equals 1. Remember, a secant line is where you choose 2 points and you draw a line that connects those 2 points. What they're telling me here is they're giving me 2 points. Matter of fact, I'll call the first point x1. They're saying x1 is 0, and x2, a second value of x, a second point, is 1/2. So they're giving me 2 points on my function. And they're saying now, go figure out the slope of the secant line that goes through those 2 points. Well, if I've got a line with 2 points, I remember my slope equation, y2 minus y1 over x2 minus x1. If I've got 2 points, I can find the slope of that line. Well, I don't have all the information quite yet for 2 points. Here's my first point. If x of 1 is 0, how do I find y of 1? You go back to your original function. Once again, we can think of this as y equals 2x minus x squared. Plug in 0 for x. What do you get for y? 0. So here's 1 point on my line, 0, 0. What happens if I plug in 1/2 in for x? What's y going to be? Well, here it's going to be 2 times 1/2 minus 1/2 squared. 2 times 1/2 is just 1. 1/2 squared is 1/4. Looks like my second point is 1/2 3/4. So here's 2 points to summarize. 0, 0, I'll call that point 1, and 1/2 3/4, I'll call that point 2. So these are 2 points on my curve. I'm going to find the slope of the line that goes through those 2 points. So I use my slope equation. y2 is 3/4 minus y1 is 0. x2 is 1/2 minus x1 is 0. Now, if you remember how to simplify complex fractions, you write the top fraction, multiply it by the reciprocal, the bottom fraction, then you multiply 6/4. So I'm going to put here the slope of the secant line is 3/2. Now, part B of this problem says use calculus to compute the slope of the line that is tangent to the graph. Whoops, 34. Use calculus to compute the slope of the tangent line of the graph at x equals 0 and compare with part A. So now they're saying, basically what they're saying is, go find the derivative. The derivative means the slope of the tangent line, and go actually find the slope of the tangent line when x is 0. So it's almost like what we've done here with the secant line. You know what they did with the secant line? They have some graph here, and they took x is 0, and here is like x is 1/2, very small distance. And they found the slope of this line. And now what they're telling us to do is just go at x equals 0, and by using calculus and taking the derivative, go ahead and find the slope of this tangent line. And then let's see how close these 2 slopes are. They should be pretty close. So now we have to go back and find the derivative of our original function. We've done this many times before now. So let's just, as h approaches 0, f of x plus h, so 2 x plus h minus x plus h squared minus f of x 2x minus x squared all over h. Now, just to save time, because this is a bunch of tedious work, I'm going to just skip ahead and say that when you do all the math, there's the equation for the derivative. So now we want to find the slope of the tangent line when x is 0. So you plug in 0, and you get 2. So So if you compare, the slope of the secant line is 3/2, the slope of the actual tangent line is 2, so still a little bit off. In other words, you know, maybe the secant line is like this, and the tangent line is like, that's a bad picture, but they're not quite the same yet. All right, so that was 34. So let me stop there. So hopefully that'll help you with some of the homework as you're trying to figure these out and finish these problems.